Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey Houston, we're now doing projectile motion type 2 problems. Now the key features of this kind of a problem is we're going to have level ground. The object lands at the same height. And the initial speed is equal to the final speed. And the velocity is not equal to 0. So that's what indicates what type of a problem we're going to go. So let's take a look at the problem that we have. So in this problem we have a soccer ball. And we're going to hit the soccer ball at an angle. And the angle is 14 degrees, we say, above the horizon. 14 degrees. And it's kicked at a speed of 22.3 meters per second. All right? And the question we want to ask is, what's the total hang time? So time in the air. We also want to know the height, the maximum height that it goes, max height, and then its final speed. So let's try and write down what we know. Okay, so again, x and y. In the dx, we don't know. We want to find that, right? So how far does it travel? I'm not sure to ask that question, but we don't know that. dy, we don't know that, and that is the question, right? That is the max height we're trying to find. We know vix, the velocity in the x direction. We know that, or we can find it pretty quickly, so that's like a check. viy, also we can check. I'll show you how to do that if you don't know. And we've also got time, and there's time is going to be consistent between both. VIY, VIX, I think we've got enough information to solve this problem. So let's resolve, as we like to say, this vector into two parts. Because we have this at 14 degrees, I can find VIX and VIY. Again, you might think of this as a vector, right? Actually, here and here, right? And this is 14 degrees. This is 22.3, but we know this to be 14 degrees. And this is the opposite. So this is VIY, this is VIX. And so I want to solve for each of them, right? So remember SOHCAHTOA. The opposite over the hypotenuse. The opposite over the hypotenuse is sine. So I can say sine of 14 is equal to VIY divided by 22.3. So I get my calculator out, clear it. Sine of 14 degrees times 22.3. So VIY, I'm going to put that over here, that's 5.4. To get VIX, same ball game, I'm going to do the cosine, right? Adjacent, cosine is adjacent of the hypotenuse. I can say cos of 14 equals VIX over 22.3. So I take cosine of 14. I push enter, by the way, and then I times it by 22.3. And this equals 21.6. So this is VIX. So I now know what those are. So let's see if we can figure out which one should we do first. Let's solve for the time of motion. Can we do that? So let's solve for time. Now, when we think about time, right, the ball, if you will, right, it's going to go this big arc, right? And we've got this VIY. But if you think about it, this is the kind of key to do the time. We're trying to solve for time. It starts here and it ends here. So the displacement for the distance, the y distance, which determines the time, is 0. So we can use the equation, if you recall, that delta d, and we'll do y, right, is equal to VIY times t plus 1/2 AT squared. But this is 0 equals the initial velocity in the y direction, which we found to be from here, and we wrote it down where? Right here. So this is 5.4. 5.4 times t plus 1/2 times, and this is going to be g. So actually this will be negative gravity. So we'll say negative 4. I didn't do it right. and we do this, this will be negative, because gravity is negative in the negative direction. And I'll just say negative 4.9, that's 9.81, divided by 2, t squared. Now we have a quadratic function, and I need to solve for, is that right? Now to save time, instead of putting this into quadratic function, because we just have these two t terms, you can do something interesting. You can say 0 equals t times 5.4 minus 4.9 t, right? And t has to be a positive number, so I need to find a t where 5.4 minus 4.9 t equals 0, right? So I want to say 5.4 minus 4.9 t equals to 0. That's how it has to be. So I can just add 4.9 t to both sides. So 5.4 equals 4.9 t. Divide both sides by 4.9. And 5.4 divided by 4.9, t equals 1.1 seconds. You could just as well plug this into the quadratic formula. If you like that method, that have worked, but you didn't have like a term that mattered. So this is the amount of time that the object will be in the air. So we now know that's important. So t, let's write that down. This is 1.1 seconds. So question 2, if you will, is we want to find how high did he travel. Again, this all has to do with the y, but now we've got the t, the 1.1 seconds. It's going to be a huge thing that's going to solve a lot of issues. Now, one thing to make a note, the 1.1 seconds is the maximum, that's for the total distance. So it's important to note what happens at halfway. So 1.1 divided by 2 is 0.55 seconds, because it's going to be at the top height at 0.55 seconds. So keep that in mind. That's kind of important. All right. Next, what we're going to do is an equation we've seen y. We've seen this again. We should say delta dy is equal to vi delta t plus 1/2 at squared, and a, of course, being the acceleration of gravity. So we're trying to find the height of d at the time of 0.55 seconds. We know the initial velocity in the y direction is 5.4, so 5.4 times 0.55, this is at time, all right, plus negative 4.9, because g is negative, acceleration of gravity, times 0.55 squared. We then just plug this into our calculator, this times this, plus this times this, and we come up with a grand total of 1.49 meters. So the highest that this ball will go will be 1.49 meters. And then the last question is, what's the final speed? We don't even need to do math on this, because if you're at the level ground, if this is kicked at 22.3 meters, you know how fast it's going to hit? 22.3 meters per second. So because they're at the same angle on the level ground, that's how you solve these problems. Notice how we solve for time. This is a trick thing. Make sure you understand this. This can be tricky because the max height happens at half the time. So that's a type 2 problem. So let's do the type 2 extension problem. So we're going to make it just a little bit harder. So in this case, we've got a girl who's trying to block the ball. So she jumps up, and we'll see if she can block the ball. Now, we know a couple things. That she's at, the blocker is at 7.4 meters. Remember, we know our VI y, and we know our VI x. And when she blocks, her body takes up a space that's, if you will, from 0.75 to 1.15, because she's now 3/4 of a meter. She's jumped. She's high. So she's jumping off the ground. The question is, does the ball go over or right into her? Now remember, time is the biggest variable. That's the thing that makes life easy, that convert things. Now we know this is 7.4 meters, and now we're going to utilize our VIX, which we, if you recall, calculate that to be 21.6. And this is a simple problem. You know, velocity is distance over time. All right, so I take the velocity, what is it? 21.6 equals 7.4 over the time. I rearrange, I solve for t, and I got the cheat sheet here. T is 0.34 seconds. And now I'm going to plug this into the y equation, see how the time jumps between distance and time, and what I can say is delta dy equals VIY times t plus 1/2. We'll say g for acceleration of gravity, gt squared. We're going to plug this t in here, find delta dy, and see if it is in this range. So the VIY, wasn't it 5? 5.4. So this is equal to 5.4. Now plugging in this 0.34 seconds plus 1/2. Actually, we'll just say negative 1/2 times 9.8 times whatever that number is, 0.34 squared. Plug that all into your calculator, trust me if you do this, and you're going to end up with delta D y equal to 1.27 meters. 1.27 meters, that is where the ball will be at 0.34 seconds and at 7.4 meters, and 1.27 meters is higher than 1.15. The ball will sail over. She will not successfully block the ball. Type 2 problems, Houston, we got this, because you guys, well, you rock. Projectile motion, not so hard. See you in class.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston,